Alright, so this is video notes for 9.3 surface area of pyramids and cones, day 1. So today we're going to talk about the surface area of cones. So first, what is a cone? A cone is a solid with one circular base and a connected vertex. So if you look at our cone to the right, the base or the bottom is in fact a circle, the only place or the only side that we can put on the bottom. And our vertex is this point here at the top. And our vertex is connected to our base, to all the sides of the circle, or to the whole side of the circle. Next, we have the height of a cone. The height is the perpendicular distance from the vertex to the center of the base. So if you look at our picture, we start at the vertex and draw a line going down to the center of our base, to the center of the circle. And since this is perpendicular, we know it makes a right angle with the base. So this is our height. We represent height with the letter H. The slant height of a cone is the distance from the vertex to the edge of the base. So here we're not going to the center of the base, but we're going to the edge of the base. So you can start at the vertex and draw a line going down to the edge of the circle. So this could be your slant height. Your slant height could also be this line out here, going to a point on the edge of the circle. We represent slant height with the letter L. So next, let's go on to the formula for finding the surface area of a cone. The formula is S equals capital B plus pi r L, where capital B represents the area of the base, which in this case is a circle, R represents the radius of the base, and L, like we said before, represents the slant height, so the distance from the vertex to the edge of the circle, to the outside. So let's use this formula in example number 1. It asks us to find the slant height of a cone. Well, our formula actually is for surface area, so we won't use our formula. We just want to know the slant height of this cone. Well, here's our slant height going across, but you can see that the slant height makes a right triangle with the height of the cone and the radius of the cone. So if it is a right triangle, we can use the Pythagorean theorem that says a squared plus b squared equals c squared. C is always our hypotenuse, or our longest side, which in this case is our slant height L. So we're going to have 5 squared plus 12 squared is equal to L squared. 5 squared is 25 plus L squared is 144 is equal to, or 12 squared is equal to L squared. 144 plus 25 is equal to 169. So we have L squared equals 169. To undo a square, we must use a square root. So we take the square root of both sides, and we get L is equal to the square root of 169, which is 13. And our units for slant height is just the distance, so our units are just going to be feet. Alrighty, let's look now at example 2. In example 2, it asks us to find the surface area of the cone. So for surface area, we will use the formula above. So our formula is S equals B plus pi r L. So we need to find B, the base, or the area of the base. Our base here is a circle with a radius of 3 feet. So the formula for the area of a circle is pi r squared. So for r, we're going to plug in 3. So we get pi times 3 squared, which is equal to pi times 9. If you plug that into your calculator and round to the nearest whole number, you will get 28. And this is feet squared, since we were talking about the area of our base. So we found B. We need to find R and L. Well, R is given to us as the radius of our base, which is 3 feet, and L, the distance from the vertex to the edge of the circle is also given us to be equal to 4 feet. So we just need to plug all this into our formula. So we will get S is equal to 28 for the area of our base plus pi times 3 for R times 4 for L. So if we multiply pi times 3 times 4 and use 3.14 for pi, we will get approximately 38 if we round to a whole number, plus 28. We add these together and we get a surface area of 66, and our units are feet squared. Alright, you are responsible for checkpoints 1 and 2 for tomorrow.